Betelgeuse is so big that if you were to place it in our own solar system,
somewhere in the constellation Orion, a star roughly 700 times wider than our Sun is running out of time. It has burned through its nuclear fuel faster than almost any star we can see with the naked eye, and when it finally gives out, the explosion will be so bright that it could be visible in broad daylight. That star is Betelgeuse, and its slow, dramatic death has become one of the most talked about stories in modern astronomy. Popular science communicators, including Neil deGrasse Tyson, have spent years fielding the same question from an anxious public. Is Betelgeuse about to explode? And if it does, will it hurt us? Today we're going to walk through what Betelgeuse actually is, why it captured the world's attention during its mysterious dimming in 2019, and what would really happen if this stellar giant finally went supernova. Betelgeuse marks the right shoulder of Orion the Hunter, a rust-orange point of light that stands out even to casual stargazers. Its name comes from Arabic, likely derived from a phrase describing the hand or shoulder of the Great One, referring to Orion himself. Over centuries, the name has been transliterated in different ways: Betelgeuse, Betelgeuse, Al-Mankib, but the star it refers to has remained one of the most recognizable objects in the night sky. Formally, astronomers call it Alpha Orionis, even though it is usually not the brightest star in its constellation. That title normally belongs to Rigel, the blue-white supergiant that anchors Orion's foot. Betelgeuse, by contrast, is a red supergiant, and its color alone tells you a great deal about its nature. Stars glow in different colors depending on their surface temperature, and Betelgeuse's deep orange-red hue reveals a surface far cooler than our Sun's. While the Sun simmers at roughly 5,500 degrees Celsius, Betelgeuse's outer layers sit at only around 3,300 degrees Celsius. Yet despite being cooler, Betelgeuse is almost impossible to miss in the sky because what it lacks in temperature it makes up for in sheer size. If you could somehow drop Betelgeuse into the center of our solar system in place of the Sun, its outer surface would swallow Mercury, Venus, Earth, Mars, and would reach out somewhere between the orbits of Jupiter and Saturn. Estimates of its radius vary depending on the method used, but most place it somewhere between 700 and 900 times the radius of the Sun. Its mass, by contrast, is nowhere near proportional. Astronomers estimate Betelgeuse contains somewhere between 15 and 20 times the mass of the Sun. That combination of enormous size and comparatively modest mass is exactly what you'd expect from a star nearing the end of its life, one that has expanded and puffed up its outer layers as it burns through progressively heavier elements in its core. Age is another place where Betelgeuse defies intuition. Our Sun has been shining for about 4.6 billion years and still has roughly 5 billion left before it becomes a red giant itself. Betelgeuse, meanwhile, is thought to be only around 8 to 10 million years old. That is not a typo, millions, not billions. Massive stars burn through their nuclear fuel at a ferocious rate, and the more mass a star has, the shorter and more violent its life tends to be. Betelgeuse was likely born large, lived fast, and is now approaching the natural conclusion of a very short, very intense stellar career. One of the strange running jokes among astronomers is that nobody agrees on exactly how far Betelgeuse is from Earth. Distance measurements for stars typically rely on parallax, the apparent shift in a star's position as Earth orbits the Sun, but Betelgeuse presents a uniquely difficult target. It is enormous, it is variable in brightness, and its outer atmosphere is diffuse and irregular, all of which make precise parallax measurements tricky. Early estimates using data from the Hipparcos satellite placed it a little over 300 light-years away. More recent studies, incorporating updated modeling of the star's pulsations and atmosphere, have pushed that figure closer to 500 to 550 light-years. Some analyses land even closer to 640 light-years. The honest answer is that astronomers have narrowed the range considerably over the decades, but still don't have a single, universally agreed-upon number. What matters most for us, though, is that every reasonable estimate places Betelgeuse hundreds of light-years away, and as we'll get to, that distance turns out to be extremely reassuring. In late 2019, something happened to Betelgeuse that had never been documented before. Over a period of a few months, the star's brightness dropped dramatically, fading to roughly a third of its usual luminosity. For a star that normally ranks among the 10 or so brightest points of light in the night sky, this was impossible to miss, and it didn't take long for the story to spread far beyond professional astronomy circles. Headlines speculated that this could be the beginning of the end, the long-anticipated countdown to a supernova. Astronomers, understandably, took the event seriously. Teams using instruments including NASA's Hubble Space Telescope and the European Southern Observatory's Very Large Telescope in Chile trained their attention on Betelgeuse to figure out what was actually happening. What they found was not a star on the verge of collapse, but something almost as remarkable. Betelgeuse appeared to have thrown off an enormous chunk of its own surface. Researchers described the event as a giant surface mass ejection, something never before observed on this scale in a star like Betelgeuse. A convective plume rising from deep within the star pushed a huge blob of hot plasma outward, and as that material expanded away from the star, it cooled and condensed into a cloud of dust. That dust cloud then drifted into our line of sight, partially blocking the light heading toward Earth, not unlike smoke obscuring a lamp from a distance. Combined with a coincidental cooling of part of the star's surface, this dust veil explained the so-called great dimming almost entirely through ordinary, if extreme, stellar behavior rather than an imminent explosion. The episode reshaped how astronomers think about massive stars nearing the end of their lives. It suggested that red supergiants like Betelgeuse may shed material in violent, unpredictable pulses long before any final collapse, offering a preview of the turbulent, restless behavior these stars display as they approach their natural limits. By 2023, Betelgeuse had not only recovered its former brightness, but had grown noticeably brighter than its historical average, a reminder that the star's light curve remains anything but predictable. Every star that begins its life with more than about 8 times the mass of the Sun is destined to end in a core collapse supernova, and Betelgeuse fits that description many times over. Deep in its interior, the star has already worked its way through hydrogen and helium fusion and is now fusing progressively heavier elements, carbon, neon, oxygen, and eventually silicon, in a series of shells like the layers of an onion. Each stage burns faster and hotter than the last. The final stage, silicon fusion into iron, takes only about a day, because iron cannot release energy through fusion. Once a star builds up a core of iron, it has no way to hold itself up against its own gravity. At that point, the core collapses in a fraction of a second, crushing down to the density of an atomic nucleus. The outer layers of the star come crashing down onto that collapsed core and rebound in a colossal shockwave, blowing the star apart in a supernova. What remains at the center depends on exactly how massive the collapsing core is. Betelgeuse is expected to leave behind a dense neutron star, though depending on the details, it's not impossible that the collapse could go further and produce a black hole. Nobody knows exactly when this will happen. Estimates place the event anywhere from tomorrow, astronomically speaking, to as far as 100,000 years from now, which in cosmic terms still counts as soon. Stars give few precise warnings before this kind of collapse. Internal processes that took millions of years can accelerate into their final phase over a span of mere centuries or less, with limited external signs beforehand. If Betelgeuse exploded today, the light from the event wouldn't reach us today. It would take however many hundreds of years its distance requires to arrive, meaning the star may have already exploded, and we simply haven't seen it yet. Whenever that light does reach Earth, the display promises to be extraordinary. Based on models of the star's distance and expected peak luminosity, astronomers estimate the supernova could shine as bright as the full moon for a period of weeks and would be easily visible during the day for several months before gradually fading over the following year or two. At night, it could cast faint shadows, and its position in the sky would remain a beacon impossible to miss for anyone on the planet, regardless of light pollution. Historically, supernovae visible to the naked eye are exceptionally rare. The most recent one observed within our own galaxy was recorded by astronomers, including Johannes Kepler, back in 1604, over 4 centuries ago. A supernova from a star as close and as famous as Betelgeuse would be an unprecedented event for modern civilization, Nothing in recorded human history compares to watching a supernova unfold from a star everyone already recognizes by name. This is the question that tends to dominate the conversation, and the science here is genuinely reassuring. For a supernova to pose any real danger to life on Earth, through radiation capable of damaging our atmosphere's ozone layer or disrupting the biosphere, the exploding star generally needs to be within about 50 to 100 light-years of us. Even taking the more conservative distance estimates for Betelgeuse, at somewhere around 500 to 650 light-years away, it sits comfortably outside that danger zone, by a factor of 5 to 10 times the distance needed for real concern. What we'd experience instead is a spectacular, harmless light show, a brilliant new point of light in Orion, a temporary companion to the moon in terms of brightness, an object of fascination for scientists and casual observers alike, and eventually a fading remnant that professional telescopes would study for centuries. Satellites, power grids, and biological systems on Earth would remain unaffected. The supernova would be a gift to astronomy, not a threat to survival. It's worth comparing Betelgeuse to genuinely nearby stars to put this in perspective. Alpha Centauri, our closest stellar neighbor at about 4.3 light-years, would be a serious concern if it were the type of star capable of a supernova. Fortunately, it isn't. Betelgeuse being over 100 times farther away than that puts any lingering worry to rest. Long before telescopes or spectrographs, Betelgeuse held meaning for cultures across the globe. Arabic astronomers catalogued it centuries ago as part of the constellation now known as Orion. In parts of the Americas, indigenous groups told stories that reimagined the surrounding stars as a hunter or chief who had lost a limb, weaving Betelgeuse into narratives about sacrifice and transformation. In ancient Sanskrit tradition, the star was associated with lunar mansions used to track time and season. Among Arctic peoples, the rising of Betelgeuse and its neighboring stars in late winter served as a practical calendar, signaling the return of longer days. Across the Pacific and in parts of Southeast Asia, the star's position relative to Orion's belt marked agricultural cycles and the start of new years. This layering of myth and meaning is part of why Betelgeuse resonates so strongly whenever new scientific findings make headlines. It isn't just a data point in a stellar catalog. It's a star that has anchored human timekeeping, storytelling, and imagination for thousands of years. When astronomers announce that it dimmed unexpectedly or discuss its eventual supernova, they're tapping into a connection between people and this particular point of light that long predates modern astrophysics. Betelgeuse is a massive, aging red supergiant that will, at some point, end its life in a supernova. That much is not in dispute. What remains uncertain is the timing. It could happen within the next few centuries, or it might not happen for another 100,000 years, and there is currently no reliable way to narrow that window further. The dramatic dimming event of 2019 and 2020, initially feared as a sign of imminent collapse, turned out to be a massive but non-terminal ejection of stellar material, offering scientists a rare glimpse into the turbulent final stages of a supergiant's life, without any actual danger involved. When Betelgeuse does finally explode, it will almost certainly be one of the most significant astronomical events witnessed in recorded human history, visible across the entire planet and outshining every star in the sky. But at its safe distance of several hundred light-years, it poses no threat to life on Earth. Instead, it offers something better: the chance for humanity to witness, in real time, the same kind of stellar death that once seeded the universe with the heavy elements that make up our planet, our oceans, and ultimately ourselves. Until then, Betelgeuse will keep doing what it has done for millions of years, flickering, brightening, dimming, and holding its place on Orion's shoulder, patiently waiting out the final act of its stellar life.